Imagine a summer road trip from your childhood. The long stretches of highway, the setting sun painting the sky, and the inevitable rhythmic asterisk thwack 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 asterisk against the windshield. Remember pulling into a gas station at dusk, the headlights illuminating a gruesome mosaic of splattered insects. You'd grab that squeegee and scrape away the evidence of your high-speed journey through their world. Now, think about your last long drive. When was the last time you had to clean your windshield like that? This isn't a faulty memory or a simple change in car aerodynamics. It's a phenomenon, whispered about by truckers and entomologists alike, called the windshield phenomenon. And it's a quiet, anecdotal alarm bell for a terrifying global truth. The insects are vanishing. We spend billions of dollars pointing our most advanced instruments towards the void, listening for a single, intelligent signal from an alien world. We analyze the light from distant exoplanets, searching for the chemical fingerprints of life, oxygen, methane, water vapor, the so-called biosignatures of a living world. We dream of finding a second Genesis, a planet teeming with extraterrestrial flora and fauna. But we may be asking the wrong question. Instead of looking for the signs of a thriving world, perhaps we should be learning to recognize the signs of a dying one. What if the most telling signal an advanced civilization can send isn't a radio message, but a profound, planetary silence? A silence that begins with the disappearance of its smallest, most crucial inhabitants. This isn't just an ecological thought experiment. This is a deep dive into what could be one of the great cosmic filters, a planetary-scale test that perhaps no technological species has ever passed. The question isn't just, what if insects vanished from Earth? The real, cosmic question is this how a planet broadcasts its own funeral to the universe? The first horseman of this insectless apocalypse wouldn't arrive on a steed of fire, but on a silent, fruitless breeze. This is the pollination collapse. It begins subtly. Your favorite apples become more expensive, then scarce. The variety of berries at the supermarket dwindles. That morning cup of coffee, that evening piece of dark chocolate, they become luxuries of a bygone era. We think of bees when we think of pollination, and their plight is well documented. But they are just the star players on a team of millions. Moths, flies, beetles, wasps, butterflies, and even humble ants are the unseen, unpaid workforce that underpins the majority of the world's plant life, including over 75% of our food crops. Without them, the global agricultural system doesn't just stumble, it shatters. Imagine a world where hand pollination becomes the norm, not just in a few specialized greenhouses, but everywhere. Armies of workers, or perhaps fleets of sophisticated, energy-hungry microdrones, would have to move from flower to flower, 24 hours a day, attempting to replicate the tireless, perfect work of trillions of insects. The economic cost would be astronomical, easily running into the hundreds of trillions of dollars annually, bankrupting nations and making all but the most basic grains prohibitively expensive for the average person. Famine wouldn't be a regional crisis. It would be a global, permanent state of being. The vibrant colors of the produce aisle would fade to a monotonous palette of beige and brown. Wheat, rice, corn, crops pollinated by the wind. But even they would not be safe for long. The intricate web of life is far more connected than we appreciate. The visual beauty of the world would be the next to go. Fields of wildflowers would become sterile green mats, their genetic lines ending without their pollinators to ferry life between them. The great forests would begin to falter, as the understory plants, the shrubs and flowering trees that form the foundation of the ecosystem, fail to reproduce. The world would become visually and genetically impoverished. From the vantage point of a hypothetical alien observer, this would be a clear and terrifying signal. Sophisticated orbital telescopes, far beyond our own capabilities, could analyze the chlorophyll density and diversity of a planet's surface. They would see our world, once a vibrant patchwork of greens and seasonal colors, slowly lose its complexity. The spectrum of light reflecting from Earth would simplify, a planetary blush of health fading to a pallor of sickness. They wouldn't need to intercept a radio signal to know our civilization was in a death spiral. They could see it in the fading colors of our continents. The silent famine would be broadcast not through sound, but through light itself. As the world starves, a second, more grotesque crisis begins. We are a planet of life and therefore a planet of death. Every second, countless tons of organic matter, fallen leaves, dead wood, animal droppings, and the bodies of the dead are returned to the earth. We don't see this process because it is handled with relentless efficiency by the planet's cleanup crew, a crew composed almost entirely of insects. This is the Great Decomposition. Termites and wood-boring beetles chew through fallen forests, preventing the planet from being buried under a mountain of dead trees. Flies and their larvae, the maggots we find so repulsive, are masters of recycling flesh, reducing a dead animal to bone in a matter of days or weeks. And dung beetles, in their quiet diligence, process billions of tons of animal waste, aerating the soil and cycling nutrients with an elegance that no machine could ever replicate. Now, imagine that crew vanishes. The process of decay, which connects death back to life, grinds to a near halt. A dead squirrel on the lawn, which might vanish in a week, now lies there for months, a slow-rotting vessel for anaerobic bacteria. A deer struck by a car on the roadside becomes a mummified statue, its nutrients locked away from the ecosystem. The great forests of the world, already struggling from the pollination collapse, would become impenetrable tombs. Dead trees would stack up like cordwood, choking out new growth and creating a tinderbox on a planetary scale. Forest fires would become continent-spanning firestorms of an intensity we can barely conceive, sterilizing the soil for generations. The very ground beneath our feet would harden and die. The constant churning and aerating of the soil by insects would cease. Nutrient cycles, the fundamental chemistry of life that turns death into fertilizer, would be broken. Our remaining wind-pollinated crops would fail as the soil loses its fertility, its lifeblood of nitrogen and phosphorus locked away in undecomposed matter. The world would begin to stink. The air, thick with the smoke of perpetual fires, would also carry the sweet, sickly smell of slow, endless decay. Anaerobic bacteria, operating without the competition from insect larvae, would flourish, releasing massive quantities of methane, hydrogen sulfide, and other noxious gases. This is a signal that would be unmistakable across interstellar distances. An alien civilization analyzing Earth's atmosphere would be baffled. They'd see the familiar signs of a technological society, industrial pollutants, perhaps carbon dioxide. But they would also see a sudden, massive spike in the gases associated with putrefaction. It would look like a planetary-scale corpse. They would detect a necrosignature, a chemical fingerprint of a biosphere undergoing systemic, catastrophic decay. Our planet would be sending a clear message. We are drowning in our own dead, a civilization presiding over a world that has forgotten how to rot. With the collapse of the food supply and the failure of decomposition, the third and most final internal collapse begins. The trophic cascade. A trophic cascade is the ecological term for when the top or bottom of a food chain is removed, causing the entire structure to unravel. Removing the insect world isn't like removing a few bricks from a wall. It's like vaporizing the foundation of the entire building. Insects are the primary food source for a staggering number of animals. Almost every freshwater fish gone, the vast majority of songbirds silenced forever. Swallows, swifts, nightjars, their acrobatic displays would vanish from the sky. Bats, our nocturnal allies against the few remaining pests, would starve in their caves. Lizards, frogs, salamanders, spiders, the small predators of the world would simply cease to be. The world would fall silent. The dawn chorus of birds would be replaced by an eerie stillness. The chirping of crickets on a summer night, a sound that has been the backdrop to humanity's entire existence, would be gone. This silence would be the soundtrack to a global extinction event far exceeding the one that killed the dinosaurs. But it wouldn't stop there. The cascade would ripple upwards. The eagles that fed on fish-eating birds would starve. The foxes that fed on lizards and beetles would disappear. The entire food web, a structure of unimaginable complexity built over hundreds of millions of years, would snap in a single generation. We see ourselves as separate from this, at the top of the chain. But we are not. Our fate is tied to the songbird and the lizard. The oceans would not be spared. Many marine fish species begin their lives in coastal estuaries, feeding on the runoff of nutrients from the land, nutrients that are carried there by rivers, nutrients that are only available because of the decomposition work done by insects on the shore. Without this nutrient flow, the base of the marine food web would be crippled, leading to a collapse in fish stocks that would make overfishing look like a minor inconvenience. The planetary die-off would be total, from the mountain peaks to the ocean floor. An alien observer would see this cascade written on the very surface of our planet. The changes in vegetation would alter the Earth's albedo, how much sunlight it reflects back into space. As forests died and were replaced by scrubland or desert, the planet would get brighter, reflecting more heat. This would trigger unpredictable, chaotic climate feedback loops. The chemical composition of our oceans would change. The planet would be visibly, measurably, transforming into a ghost of its former self. A world still orbiting its star, still with water and air, but with its living soul ripped out. In the face of this planetary unraveling, humanity would not be idle. Our response would define the final act of our civilization. This is where the Great Filter hypothesis gets personal. A great filter is a proposed challenge or barrier that is so difficult to overcome that it prevents most intelligent life from becoming a multiplanetary, long-lasting species. It could be the jump from non-life to life, or from single-celled to multi-celled organisms. Or, perhaps, the filter is late stage, the challenge of managing a global technological civilization without triggering self-destruction. The insect apocalypse presents a chillingly plausible candidate for such a filter. Our initial response would be one of technological arrogance. We'd deploy the pollination drones, we'd build massive, industrial-scale composting facilities to mimic the work of beetles and flies. We'd synthesize artificial nutrients to fertilize our dying soils. But the sheer scale would be our undoing. How do you hand-pollinate a rainforest? How do you build a machine to replace the soil-aerating work of 1 billion ants in a single acre? The energy requirements alone would be staggering, demanding more from our already strained power grids than we could possibly supply. We would be spending all of our energy, all of our resources, all of our intelligence, just to poorly replicate the free, silent, perfect work that the biosphere once did for us. This is the ultimate trap. Our technology, which gave us the power to inadvertently destroy the insect world through pesticides, habitat loss, and climate change, would prove utterly incapable of rebuilding it. Our intelligence would have created a problem that our wisdom was insufficient to solve. Society would fracture under the strain. The famines, the diseases born from decay, the economic collapse, this would lead to wars over the last fertile lands, the last clean water. But perhaps the most profound impact would be psychological. What does it do to the human spirit to live in a silent world? A world without butterflies, fireflies, or the hum of bees. A world of decay, monotony, and loss. The natural world has been our source of inspiration, our metaphor for renewal, our spiritual sanctuary for millennia. To lose it would be to lose a part of our own humanity. We would be a species living in a planetary museum, surrounded by the ghosts of what we had lost. From space, the lights of our cities would still blaze, a poignant testament to a species that could reach for the stars but failed to protect the ground beneath its feet. An alien observer might see those lights and conclude that the civilization was still there, still functioning. But by analyzing the failing biosphere around those lights, they would know the truth. They were looking at a ghost, a technological species, trapped on a dying world of its own making, having failed the final, most important test. So we return to our place in the cosmos, staring out at the great, silent void. We listen for our counterparts on distant worlds, wondering why space isn't teeming with the radio chatter of ancient, wise civilizations. The Fermi paradox, the eerie contradiction between the high probability of alien life and the complete lack of evidence for it, haunts us. We've imagined cosmic catastrophes as the answer. Gamma-ray bursts, rogue black holes, self-replicating robotic berserkers. We've imagined sociological answers. Perhaps advanced civilizations inevitably destroy themselves in nuclear fire or transcend into some unknowable digital reality. But the story of the insects offers a more intimate, more terrifying, and perhaps more likely solution. The Great Filter may not be an external cataclysm or a sudden, violent end. It may be a slow, quiet unraveling. It may be the cumulative weight of a billion small, seemingly insignificant cuts to the web of life. A pesticide used here, a wetland drained there, a degree of warming accepted as the cost of progress. It is the death of a planet by a trillion tiny dismissals. The ultimate irony is that the very intelligence that allows a species to develop technology and contemplate its place in the universe is what sets the trap. We become so focused on the grand and the powerful that we forget the small and the essential. We build particle accelerators to probe the nature of reality while ignoring the disappearance of the beetles that recycle that reality. We design starships to escape our world while poisoning the very pollinators that make it a world worth living on. The silence from the stars might not be the silence of empty worlds. It could be the silence of worlds that have passed through this filter and failed. Worlds where intelligence flickered for a few millennia, long enough to illuminate its own planet, but not long enough to learn how to live with it. They too may have had their windshield phenomenon. They too may have noticed the silence, but noticed it too late. Our search for extraterrestrial intelligence is, in the end, a search for ourselves, for a reflection that tells us we are not alone. But perhaps the most important signals we should be studying are not those from the depths of space, but the fading whispers from our own backyard. We search the cosmos for signs of intelligence, but perhaps the silence we hear from other worlds isn't from a lack of life, but from the forgotten hum of the last insect that ever flew.